Welcome back. Today, we're going to talk about something every single coder runs into. That moment when your beautiful script starts to look, well, messy. We're going to take that code clutter and turn it into clean, powerful, reusable tools using one of Python's absolute best features, functions.
You know the feeling, right? You write this perfect little chunk of code and you're so proud of it. And then you need it again over here and again over there. And before you know it, you're just hitting copy, paste, paste, paste. We've all done it. But there's a much, much better way.
So take a look at this. We're calculating the BMI for 3 different people. It's the exact same logic, just with different numbers plugged in. Now, this isn't just ugly to look at, it's a total nightmare to maintain. What happens if you find a tiny mistake in that formula? Well, you have to hunt it down and fix it in 3 different spots. That is code clutter, and that is what we're here to demolish today.
So how do we fix it? Simple. We build a tool. And in Python, when you want to bundle up a piece of logic to use again and again, you build a function. And it all starts with one little 3-letter keyword, def.
So what exactly is a function? Think of it like a recipe in a cookbook. It's a named set of instructions, that's the named block of code, that does one specific thing, like make chocolate chip cookies. The keywords here are reusable and specific task. Instead of writing out the whole recipe every time you want cookies, you just say, let's use the cookie recipe. And making one is super simple. It's a 4-step pattern. You start with def to tell Python, hey, I'm defining a new tool. Then you give it a clear descriptive name. You add a pair of parentheses, we'll talk more about those in a sec, and then you end the line with a colon. That colon is key. It tells Python everything that's indented below it belongs to this function. Let's go back to our BMI mess and apply this. We just wrap all that calculation logic inside a function that we'll call, you guessed it, calculate_BMI. Just like that, those 3 messy blocks of code become one single clean tool. So congratulations, we've made our first function. But it's not super useful yet. It's rigid. Let's fix that. A tool that only does one specific thing is fine, I guess, but a tool you can adjust, that's a game changer. We're about to make our functions truly powerful by giving them a way to take things in and give something back. So, how do we make it adaptable? Remember those parentheses? Well, they're not just for decoration. They're the front door for our data. By putting names inside them, we call these parameters. We're creating little placeholders. Here, height and weight are just waiting for us to give them some values. Now our function is flexible. We can give it any height and weight, and it'll work. We can even make our functions a little bit smarter by setting up a default value. See that unit equals metric part? That's so clever. It means if you don't bother to tell the function which unit system to use, it'll just assume you want metric. It adds more power without making it harder to use for the simple cases. It's really the best of both worlds. I love this analogy because it's just perfect. A function really is like a blender. You put your ingredients in, those are the arguments, like height and weight. The function does all the work, the whirring and mixing, and then you get something useful out. That's the return value, your smoothie. And this is how we get the smoothie out of the blender. The return keyword is the function's way of handing something back to you. It basically says, okay, my job is done, and here's the result you asked for. In this case, our function does the math to convert Celsius to Fahrenheit, and then it returns that final number so we can actually use it for something else. Okay, this next part is, well, it's absolutely crucial. Every variable in your code has a place where it lives. We call this its scope. And once you get this, a whole category of really confusing bugs will just disappear. And there are basically 2 neighborhoods they can live in. On the left, you've got local scope. Think of this like what happens in Vegas stays in Vegas. Any variable you create inside a function is local. It only exists there, and once the function is finished, poof, it's gone. Then on the right, you have global scope. These are variables out in the open that any part of your code, including any function, can see and access. Now, a really, really important piece of advice. Even though your function can see those global variables, it's almost always a bad idea to let it change them. Why? Because it creates these mysterious side effects. You'll have a function running and it silently changes some variables somewhere else in your code. All of a sudden your program acts weird and you have no idea why. It's much, much safer to keep your function self-contained. Pass data in and return a result out. So we've built an awesome reusable tool. That's great, but what happens when you have 10 tools, 100?
Your main script starts getting cluttered again, so now it's time to get organized. We're going to build a toolbox, and in Python, we call that toolbox a module. And what is this fancy-sounding module? You're going to love this. It's just a Python file. Seriously, that's it. Any file that ends in .py can act as a module. You can have a mathtools.py, a texthelpers.py. It's like having a perfectly organized spice rack for all your different code recipes. Let's see it in action. It's so easy. We just take our finished calculate BMI function, we cut it from our main script, and we paste it into a brand new file. Let's call it utils.py. That's step one. This file is now officially our utilities module. It's a toolbox, and right now it's got one tool in it. And now for the magic. Back in our main file, main.py, we just add one line at the top, import utils. That's it. That one line connects our main script to our toolbox. And now, to use our function, we just type the name of the toolbox, a dot, and the name of the tool, utils.calculate BMI. Look how clean and readable that is. We know exactly where that code lives.
So let's just pull this all together. Why did we do all this? First, the dry principle. Don't repeat yourself. It saves time and kills bugs. Second, reusability. You write a tool once and you can use it in a dozen different projects. Third, organization. No more giant, messy script files. And finally, clarity. Good functions make your code read like a story, and that is a gift to your future self.
Think about it. We went from a tangled mess of copy-pasted code to building a clean, organized, reusable toolbox. This is one of the biggest leaps you can make as a programmer. You don't just write code anymore, you build tools. So the only question left is, what amazing tool are you going to build next? Thanks for joining me and happy coding.